Structural patterns. Structural patterns are the patterns that are concerned with composition, class or object composition, and we are going to take a look at 6 structural patterns: adapter pattern, decorator pattern, bridge pattern, Flyweight pattern, proxy pattern, and composite pattern. So let's start with the adapter pattern. I would say adapter pattern is probably the most straightforward pattern in all structural patterns. The adapter pattern allows otherwise incompatible classes to work together by converting the interface of one class to the interface expected by the client. So example scenario could be that you happen to have a third-party library in which you have a class that you want to use, and you don't have a source code and you do not have a way of changing it, so you have to use it as it is basis, but the interface is not what you want to use for. So in this case, you are going to introduce an adapter interface which you're going to use in your client code, but internally it will invoke adapt-t, meaning that old third-party class will be used. Pretty straightforward. So participants. So adapter interface. So this is the adapter. This is the interface that you want to use, meaning your client code want to use. Okay. And then implementation of this adapter interface is going to be adapter class, and internally it will have a dependency object of adapt-t. So adapt-t will be injected into this adapter class. Okay? And internally it will call an API of this adapt-t class. It's pretty straightforward. Okay, so let's do exercise 1. So exercise 1 is the adapter. So I have imported the class. So adapter. So in this case, basically, let's take a look at the switch example. So we have old TV class. So this is maybe from a third-party vendor library, and it does have turn knob to the right and turn knob to the left. Okay, so old TV in fact used to have this knob for turning on and turning off. So in order to turning on, you have to actually turn it to the right, and in order to turn it off, you turn it all the way to the left and things like that. And this is certainly old way of actually turning on and turning off the TV. So what we want to use is we want to use on and off interface like this. This is the code that we want to use. remote control on and off. Okay? And we are going to have an implementation class called the remote control, which implements this remote control, and this old TV object will be injected. Okay? And basically that implementation of on and off is using this old TV. So client code is using just new interface remote control, and when it calls on internally, this remote control object is going to use old TV's API. Okay, so pretty straightforward. So that's a switch, switch example. Let's take a look at the general class cases. So if you take a look at the class diagram, we have adapter, and we have adapter implementation class, which has a reference to adapt-t, and client will just use adapter interface. Okay, and so adapt-t contains method b. This is the old method, and adapter has a reference to adapt-t. So you can see adapt-t is a dependency object in adapter class, and it's injected through the constructor. And this method A is from adapter interface, and that interface method A, it will call adapt-t's method B. Okay, so again, key aspect is the client code does not need to be tied up with old classes method. Okay. All right, so pretty straightforward. Let's do the homework. Let's see the homework. So you are going to, yes, let's see, adapter greeting homework. So the one that I want you to work on is you want to use all greeting class using new interface, new greeting interface. And all greeting takes a single string argument, while the new greeting interface takes a 3 arguments. So greeter and greetee and the message. Okay. So you want to uncomment this client code, and your job is to create all greeting class and greeting interface and new greeting class. It's pretty straightforward. Okay. I'll give you guys 10 minutes to do this exercise.